Good morning, dear students. Today we will discuss the next point in the quantum mechanics, that is Heisenberg uncertainty principle. So before starting this Heisenberg uncertainty principle, we will see where we can apply the Heisenberg uncertainty principle. So the Heisenberg uncertainty principle applies only on microscopic particles. So you can apply it only for the microscopic bodies or the microscopic particles. Then it is used to calculate the probabilities for where things are and how they will behave. So as I said, the Heisenberg uncertainty principle is only applicable for the microscopic particles like electron, proton, neutron. So if you want to calculate the probabilities of where is an electron and how they will behave, then you have to apply the Heisenberg uncertainty principle. So let us see what is Heisenberg uncertainty principle. So uncertainty principle statement says it is impossible to determine the exact position x, here position we will indicate it by x, and momentum which is indicated by p of a moving particle simultaneously. So you cannot find out the exact position and the momentum of a moving particles simultaneously if the more accurate we know one value. For example, I want to find out the exact position with less error. So more accurately we know one value, that is, if I know the value x, then the less accurate we know the other value. The value of momentum or p will be less accurate. Now if we write it in the form of an equation, we can write it multiplying together the errors in measurements of position and momentum has to give a number greater than or equal to h divided by 4 pi. Now multiplying both the errors, that is error in position and error in momentum, then it will be always greater than or equal to h divided by 4 pi. H is the Planck's constant and whose value is very less. All of you know it, right? So we can write delta x into delta p is greater than or equal to h divided by 4 pi, where delta x is error in position and delta p is error in momentum. So here this delta x is not a position, it is error in finding the position value, and delta p is not momentum, it is the error in finding the momentum of the particle. So when we go to find out the exact location or the momentum of a particle, one parameter we can find it accurately, whereas there will be uncertainty or error in the other parameters, and it will be vice versa. Okay, so the multiplication of these two is always greater than or equal to h divided by 4 pi, and this value remains constant. H is a universal constant, so this value always remains constant. So only variation will be delta x or delta p, that is error in finding the position and error in finding the momentum. If I want the exact value of position, So I will minimize the error in position, but there will be maximum error in momentum. If I want to know the momentum of that particle accurately, then I will reduce the error in momentum, but there will be huge spike in the error of a position of particle. Similarly, we have other two conjugate pairs and the uncertainty. Those are given here. So this is about the Heisenberg uncertainty principle.